In this video, we're going to look at the following question. A statistics student has surveyed the SSC and found the following. 11 people are just studying, 4 people are just hanging out, and 6 people are working with a tutor. If 4 people are chosen at random, what is the probability that exactly 2 are working with a tutor? So let's see if we could solve this question. I'm going to go ahead and pull out some of the important information. Obviously, we've got a few important numbers here, but the thing that stands out to me first is that I have to find the probability. So we have to make sure we know what probability is. Now, I've got a few resources open here. This is the statistics page on the SSC's website. I've also got a Desmos scientific calculator open, so we can do some calculations. And on the SSC stats website, or stats section of the website, in chapter 3, you're going to find we have a couple different resources here. I'm going to use a few of these. The first one, the basics of probability. And this talks about probability is and goes through some examples, but what I want to focus on right now is this basic formula right here. The probability of any given event is the number of ways that this event can occur divided by the total possible outcomes. I want to start us there. So probability of an event equals number of ways the event, whatever it is, can occur, divided by the total possible outcomes in this scenario, whatever the scenario is. All right, so that's the basics of probability. And usually when I'm doing a probability problem, I actually start with the total. I start with the denominator. That's usually the easiest thing to find because it is the most generic part of the problem. I need to find the total possible outcomes in this scenario. And so that's actually what I'm going to start with. So if I'm going to be finding the total possible outcomes, I should start by finding the total number of people that were looked at or that were found in the SSC. 11 were studying, 4 were hanging out, 6 were working with a tutor, so that gives us a total of 21 people. 21 total. All right, so that's important, 21. But I'm not just picking one person. According to the question, 4 people are being chosen at random. So there are 21 possible people to choose from, and I'm choosing 4 of them. Now I need to decide, is this combinations or is this permutations? And so for that, we actually do have another resource. If you go back to the SSC stats page, we have permutations, combinations, and factorials. And this goes through each one, what it is, some keywords to look for. And we also have 2 pages worth of example problems, as well as a flowchart to help you determine which one you're going to be using. So this is a handy resource to have. So for us, let me look at that flowchart here. So are you dealing with a finite set? We are talking about people. So yes, that is a finite set. So I'm going to go over here to the left side of the chart. Does the order of placement matter? Now, if I reread my question, it says 4 people are chosen at random. What's the probability that exactly 2 are working with a tutor? There's no mention here about order. There's no first place, second place, third place. There's no president, vice president. There's no mention of order whatsoever. And so I'm going to say no, order doesn't matter. So I'm going to use combinations. Now you might have done this already, and if so, awesome. So that's our total. Our total possible outcomes is 21 choose 4, or 21 combination 4. So that's the total. Let's look at the more specific part now. We want the probability that exactly 2 are working with a tutor. 2 are working with a tutor. Okay, well, how many people total were working with a tutor? 6. Okay, and we already know this is combinations. So you're never going to have a problem that mixes combinations and permutations in a probability question. It's going to be one or the other. So we already determined this was combinations. 6 people are working with a tutor. We want exactly 2 of those people from our sample of 4. So this looks pretty good, but one helpful tip when you're working with probability and combinations is that the numbers before the C in the numerator and the denominator should add up to be the same. And then after the C should also add up to the same. Now, obviously, I'm missing something because 6 does not equal 21 and 2 does not equal 4. So I'm missing something. Let me show you what I mean. If only 2 people are working with a tutor, what about the other 2 people? Because there are 4 altogether, right? 4 people altogether, 2 people are working with a tutor. That leaves me 2 left over that must be doing something else besides working with a tutor, which means they could be studying or they could just be hanging out. And the question didn't specify which, so I'm going to assume it could be any of these 15 people. And I need 2 of them to complete my set of 4 people. Now check this out. This may not be a revelation to you, but it's pretty cool. So 6 plus 15 is 21. 2 plus 2 is 4. This is a nice way to check to make sure that you've included all the information that you need. So we have 6 people working with a tutor. We want exactly 2 of them. But there are 15 other people who are doing other things, and we need 2 of those to finish our group of 4. So this is how we're going to calculate the probability that if 4 people are chosen at random from this group, what is the probability that, or I said probability, but what's the probability that exactly 2 are working with a tutor? This is the equation I need to go ahead and put in my calculator. Now, I'm not going to do this by hand. You may see this by hand in some other videos. I'm actually just going to go ahead and throw this into Desmos. So let's do that. Okay, so here's the Desmos calculator that I mentioned to you before. Now this is probability. Probability can always be written as a fraction, and usually when we're calculating it, that's how we start it, and that's what we did here. We have a fraction, so I'm going to press this A over B button to make a fraction here. And the first thing I have is combinations. So let's open up the function menu to get combinations. So if I hit the function menu, sometimes it automatically, when I do this on my computer, it kicks me out of the top of the fraction, but I'm just going to click back into the top to make sure I'm still there. Now I've got combinations, and my first combination is 6 and 2. When doing combinations, you always want to put the bigger number first, whether you're doing it by hand, writing it out, or you're putting it into a calculator. We're going to do 6 first, and then a comma, and then a 2, and close parentheses. And I'm going to multiply that, go to another one, back to main, 15, comma 2. So this is how you can use Desmos calculus. So I've got 6 people working with a tutor, 2 have been chosen at random, 15 other people in the SSC, and then the other 2 more have chosen to finish off the group. I'm going to click down into the denominator of my fraction to finish this off. Let's go back to function, choose one more combination. There are 21 people total, and I have chosen 4 total for my example. And here is my probability right here. Now this is put it as a decimal. If you need a fraction, you can press the fraction button. It looks like the probability is 5/19, or 0.26. Let's say we're going to run this. Actually, let's run this to the nearest thousands, just for the heck of it. So 0.263. That's the probability that, let's reread the question, that if 4 people are chosen at random from this particular group, the probability that exactly 2 were working with a tutor is 5/19, or 0.263, or you could say it's about 26%. Probability can be written as a fraction, a decimal, or as a percentage. So however your homework wants it, it'll specify. But I like to give it in several different ways because it's kind of interesting to interpret it differently. Like for instance, lots of times when you hear probability, you're not going to hear, oh yes, the chance of rain is 0.263. You'd probably hear 26%. Probably wouldn't hear 5/19 either, but I think percentages is probably what we're most familiar with. But lots of times we write it as a decimal for us stats class, or sometimes as the fraction. But it's nice to see that all 3 of these things mean the same thing. For this problem, it means the chance that 2 people out of 4 chosen are working with a tutor. Hopefully they're working with a tutor on a question like this and it's going well. So that's it for this video. If you have any questions, please feel free to let me know. I wish you the best of luck.